what is line charge density. In order to calculate the total amount of charge in the line, we have to use line charge density. In order to calculate the total amount of charge in the surface, we have to use surface charge density. In order to calculate the total amount of charge in the volume, we have to use volume charge density. Okay, density in the sense how much charge present in that particular length, surface, volume. We have to find out. Okay, so this is what the basic thing that we have to find out. Okay, this is one of the basic concept that we should know. This is a topic called electric field due to continuous charge. Okay. So now, from this expression, now I am going to derive further. Okay, I am not going to derive, I am going to rearrange the expression. So this is what line charge density. So I have drawn a line with respect to the charges. So we got this line charge density equation. Suppose if the line is very small, so this line will be represented as dl. If the line is very small, the line will be represented as dl. So the charge present in this dl will be dq. Am I right? Small charge, small length. Okay. So this will be the new expression which is obtained for a small length with respect to that particular charges. So what will be the unit of this particular line charge density in the sense? What will be the unit for the charge?
Coulomb.
What will be the unit for length?
Meters.
Meter. Coulomb per meter will be the unit for your line charge density. Okay. So now what I am going to do in the sense, now I am going to take this expression. So that is what the unit for your line charge density is written over here. So now I am going to take this one. So if you bring this dl to other side, we will get an expression of dq is equal to differential charge is equal to rho L dl. We will get this one. Am I right? This is what the differential charge present in differential length. Okay, that means the small amount of charge present in small length. Okay, that is what the meaning of this one. So in order to calculate the total charge in that length, what we have to do? In order to calculate the total charge in that length, what you have to do?
Integration.
Integrate. So Q is equal to integrate rho L dl. So this is what the total charge present in the length. First we will find out for small length, then we will integrate it for that one. It is applicable for the entire length. So this is our motto. Okay, we will find it for small portion, then when we integrate it, it is applicable for the entire length. This is our usual principle of doing any electric field concept or magnetic field concept. Okay, now this is what the expression for your differential line. Okay, now the next thing we are going to see something called the surface charge density. The surface charge density in the sense we got a surface over here. So in that surface we have entire charges. So the total charge, surface is going to be represented as rho s is equal to q by s, or otherwise it is represented by r. It will be represented in most of the books. It is represented as s. In some of the books it is represented as a. Both are same. Surface it is directly representing area. Okay. So if the surface is, if in order to find out that electric field for the entire surface, we will take a small portion of it. We call this particular surface is going to be small ds. Small ds in the sense it is going to be called as a differential surface. That means small surface. Okay. So the charge present in this small surface will be dq. Small surface will have small charges. Minimum amount of charges. Okay. So minimum amount of charges is represented as dq by ds. Okay. Now, or else it can be represented by dq by dA. Okay. So what will be the unit for this one? The charge unit is going to be coulomb. Surface will be measured in terms of area.
Meter square.
So that is what it is represented as coulombs per meter square. Okay, I have not done any imaginary concept. Everything is obtained from the known concept. Okay, you all we will have know the basic concepts of it. What is charge? What is the unit of charge? What is area? What is the unit of area? From that one, we are going to get it. We don't have to remember anything. From the concept itself, we can gather all those data. Next, so from this expression, I'm going to take these two things. Okay, now I'm going to solve it. So here, I'm going to bring this ds to other side. So this is what your rho s is equal to dq by ds. Okay, I've written it separately over here. From this one, this expression can be rewritten like this. In order to find out the total amount of differential charge. Total amount of differential charge in the surface. Differential charge in the sense small amount of charge. Differential surface in the sense small surface. Okay, rho s is nothing but the surface charge density. So here this is for the small charge. So in order to calculate the total charge in the entire surface, we have to do integration. Q is equal to integration of rho s ds. Okay. Similarly, when you come to volume, so we have taken a small volume. Okay, and then in that volume we have a lot of charges. So general expression for volume charge density is rho v, rho suffix v, q divided by v. Q divided by v. What is q in the sense? Charge, total charge in total volume. Okay. So if it is a small volume, so it is small volume in the sense it will be represented as dV. So the charge which is present in dV, small volume, it is going to be called represented as dq. So the total charge, okay, what will be the unit of this volume charge density? So this is charge will be coulomb. So when you come to volume, you will have meter cube, length, breadth, and height. So it is meter cube. So this will be the unit of this. Okay. So now from this concept, we are going to calculate the total charge. How will we calculate the total charge in the sense if we bring this dV to other side, we will get the differential charge. dq is equal to rho v dV. Now if you integrate it, you will get integration of rho v dV. So this is for the final expression of your differential charge, differential volume, differential surface with respect to charge density. Okay. So am I clear with this concept? Can I move to the next one? The next one is very important thing. Okay. We are going to apply everything from the basic concept. We are not going to study anything new. Can I move further? Or else if you want any doubts, you can ask me. Okay. Thank you. So I will move to the next slide. So this is, you can start solving with me because it is very important. If you remember once, the rest of the derivations are very, very simple. Okay. So it is only one page derivation. Everything is obtained from the diagram. Okay. So what is this? Is application of your electric field. Okay. We are going to study the applications.